Hello.
It's nice to have you. So, Jan is the managing director of beeOLED, and he'll be telling us about deep blue OLED emitter combining efficiency and stability by using intra-metallic transitions.
So thanks for introducing me. As said, Jan Blochwitz-Nimoth, CEO of beeOLED from Dresden, Germany. And my talk will focus around a stable and long-living blue OLED emitter, which is still the holy grail in OLEDs for 10 years or so. So we at beeOLED gave this problem a fresh thought and came up with a new solution. And we call this inter-metallic emission or blue elementary emission. That's where the BEE comes from. It's not a bee, the little animal, but blue elementary emission from metal ion. So content of my talk will be to describe the problem, the in our view best solution, the intermetallic emitter, and then share some results from our work. Problem definition always comes first. As I don't know if all of you know by heart what an OLED display is, I try to summarize it on one page in comparison to an LCD display, which is on the left side. So liquid crystal displays, that's the flat panel display since the 1990s. And they consist of a backlight, and then you have two polarizers. Between the polarizer, you have a liquid crystal film. That orientation you can manipulate by the electrical potential from a TFT, so it's thin film transistor backplane. And so it's a pretty complex device. In contrast to that, here on the right-hand side, an OLED is much more simple. Still, you need a TFT, and you need still make millions of pixels. You process red, green, and blue OLEDs above this TFT by a parallel process, or let's say by three parallel processes. And then you need and that's it basically. You need some encapsulation. Usually, then your display would be a mirror, and mostly you don't like it, at least not for your smartphone. So you put one polarizer above this, which makes it a black appearance if it's switched off. So the display is much more simple and has several and therefore many advantages for flat panel displays. So meaning in my view or in our view generally, the best display technology is OLED for everything between smartphone and TV size. So smartphones, IT displays, and TVs. Because the color is perfect, contrasts are perfect, switching speed is perfect, and due to the simple structure which I shown to you on the previous slide, you can make them bendable or transparent, much easier than liquid crystal displays. So you have lots of innovation in front of us in OLED. And I always say it's basically all the Hollywood filmmaker dreams I have watched from the 1990s, so my entire life basically come true with the help of OLED. So remember Minority Report or other science fiction movie. So that's all really nice. But how come that OLED covers only a small portion of the market when you get to everything between IT display and TV display? So forget smartphones, everything which is bigger, OLED has just 5%, and liquid crystal displays are still dominating by far with 95%. So why is that? Yeah, in smartphones, it's better, it's 50-50 share, but not in bigger displays. And in our view, the main reason is simple. There is no long-lasting and efficient deep blue emitter. And this limits the overall efficiency of this display. Green and red are okay, but blue is low efficiency, so the overall OLED efficiency is lagging behind LCD efficiency. And it's kind of hurting even from a carbon dioxide perspective. 1.5% of all electrical energy created by mankind is used for watching TV. That's a surprisingly big number. So even from this perspective, it doesn't definitely make sense to work on the efficiency. And there's another impact, which is difficult to understand, and I don't have time to share it here, but the production cost of such an OLED TV display is pretty big, much bigger than liquid crystal displays. The reason again is here that you have to make RGB OLED displays side by side and cannot use other structures where blue OLED efficiency then plays a major role. So therefore, the blue efficiency also limits this switch to a more cost-effective manufacturing technology for OLED displays. So better blue is really the last problem OLED has to solve. So now let's look in the options you have if you want to make any kind of light emission. Yeah, red, you need three colors, red, green, and blue. Here I focus more on the blue, but what I tell you on this slide is basically a little bit comparable to all colors. So you have the fluorescent approach, which is by nature limited in efficiency because in an electro-driven device like an OLED, just 1/4 of all excitons